Okay, now that we're on lesson 2, did you guys make a rectangle with this expression? Yeah? So, yeah, on your board, you want to make the rectangle. The 2x squared plus 7x. The camera is on. Okay, so I'll just have to do it with you guys. I'm just going to draw it out. So tell me what it looked like, your rectangle here. So we had 2x squareds. So your 2x squareds, they always go in the corner. So you had 2x squareds. So 1, 2. Now, where did your x's go? How many x's did you have on this side? 3? There is a process. You have to make a rectangle. So 3, 1, 2, let's try it. 3. Okay. It might fall off a bit. Now, and then how many x's did you have here? 1, 2, 3, 4, and then last, how many ones? 6 ones. 1, 2, 3, 4, 5, 6. So then, there we go. So let's figure out what one of the sides, one of the dimensions is 2x's plus 3. 2x plus 3 times the other dimension, x plus 2. It runs out of room on those boards, x plus 2. So that would be, so these two are equal. 2x squared plus 7x plus 6 is the same thing as 2x plus 3 times x plus 2, right? Length times width. So we're going to, if you can draw that in on your page, we're going to do one more. So let's turn to the next page before we look at. Okay. John, you can catch up later. Okay. All right, so let's try one more. I want you to try now 5x squared plus 7x plus 2. You're not going to be able to fit this most likely on your board. 5x squared plus 7x plus 2. So you might have to either, probably won't be able to fit it on your board. Let me see if I can get this working one more time. 5x squared. Oh, there we go. Okay, so I was having issues here. Okay. Okay, so 5x squared. Now, the x squared, is there a way to just make a square with 5x squared? Can you actually make a square with it? We want 7x. No. So in this case, we're going to have to put them this way. 1, 2, 3, 4, 5 long. See if I can zoom out a little bit more. You can see my arms. They always look weird on here. There we go. 1, 2, 3, 4, 5. Now we have 7 x's we need to fit on here. 7 x's. And 2 ones. 2 ones. Now remember, the ones always have to fit in the corner. So they'll either have to go like that, or they'll have to go like this. They always go kitty corner to the last x squared. They're always diagonal to it. So how could we place these x's, the 7 x's, to make a rectangle? 2 and then 5. 2 and 1, 2, 3, 4. Jesse, watch your language. I know, and I'm willing to say it on there. Okay. So, let's draw that on a piece of paper. So, what's one of the dimensions? 1, 2, 3, 4, 5x plus 2 and 1x plus 1. So that would be the answer. Okay, so we're going to draw it out. So we have 5 x's. So it might be easier just to make a rectangle and then we want 5 of them. 1, 2, 3, 4, 5. So it's not very square-like. So there's our 5x squareds. Then we had how many x's on the side? We had 7 total. So on this side, 1, 2 x's. On the bottom, each had 1 underneath, total 5. And then our 2 little red ones, 1, 2. Okay, so our dimension became, there was 5x plus, so remember this is 1, 2, 3, 4, 5 plus 2. 5x plus 2, and this side was an x plus 1. No, just 2, because the dimension of that side is just a 1 value. And so those are the same thing. That's the factored form. No, so if we FOILed this out, remember this represents the area, and this would be length times width. And so they're equal to each other. If we FOILed out our factored expression, we get our original expression. Right? It's like going backwards. All right, so we're done with the algebra tiles, so why don't we throw them away? Not like in the garbage, just in the bag. Okay, so going back to the very front page here, what I'd like you to do is I want you to FOIL out each one of these. So 2x plus 1 times 3x plus 4. So let's FOIL that out. So let's review how to FOIL. Okay, so we want to distribute the 2x into both of these to start. So first, 2x times 3x. 6x 6x, x times x squared. Okay, 2x times 4, 8x. Go back to the previous page. Now the 1 we're going to distribute into both of them. So 1 times 3x plus 3x, and then plus 4. And what's the last step? Add the 2 middle terms. So 6x squared plus 11x plus 4. So let's fill that in. So 2x plus 1 times 3x plus 4 was 6x squared plus 11x plus 4. So what that means is that 6x squared plus 11x plus 4 can be factored to 2x plus 1 times 3x plus 4. How can we do that? Well, we have 2 methods, algebra tiles, or we're going to learn an algebraic approach. So again, let's try foiling this one out now. 3x minus 2 times 4x plus 3.
Edit your audio while you get like really mad at somebody on the video.
Yep. I think it's higher. Okay, Dean, 3x times 4x. 12x squared. 3x times 3, 9x plus 9x. Now negative 2 times the 4x minus 8x, and negative 2 plus 3 times positive plus, Jesse, minus 6. Okay, 12x squared, we add like terms, so 9 minus 8 plus x minus 6, or plus 1x minus 6. Okay, so when we FOIL, we get 12x squared plus x minus 6. So that means that somehow 12x squared plus x minus 6 can be factored to 3x minus 2 times 4x plus 3. Okay? So we're going to look at how do we do that. And we're going to learn about decomposition, which we did it last year. We're going to review again. So consider the following problem. 2x squared plus 7x plus 6. That's the one we had here. So we need to find two binomials whose products produce, when we FOIL it out, 2x squared plus 7x plus 6. And we found those, right? That was 2x plus 3 times x plus 2. How could you check your work to make sure that was right? FOIL it out. That's one method. Okay, so moving back down to this page. Okay, so a warm-up. We're going to go through part of this today, and the rest of it we'll have for tomorrow, and tomorrow you'll have a bunch of homework time. Well, Monday, Tuesday. Okay? Okay, so we factored in warm-up A 3x squared, or 6x squared plus 3x plus 8x plus 4, or 6x squared plus 11x plus 4 to get this. 2x plus 1 times 3x plus 4. So how do we change the 6x squared plus 11x plus 4 into something with 4 terms? Because if it's 4 terms, we can use grouping. And that's basically the method of decomposition. We want to break up that middle term. So we want to break up 11x to 3x plus 8x, and then we have 4 terms and we can use grouping. So how do we figure that out? So why didn't they use 2 and 9? Or why not 5 and 6? What doesn't times? So let's look at the first number and the last number. So notice 6 and 4. So how are 8 and 3 related to 6 and 4? Is there a relationship there? You're close. Let's look at this next example. How are 9 and 8 related to 12 and 6? They multiply to the same thing. 8 times 3, 24. 6 times 4, 24. Okay? 12 times negative 6, does anyone know what that is? Negative 72, is that what you said? And 9 times 8, negative 72. So they're going to have the same product. So notice the sum of 8, 3 and 8 are 11, the middle term. So that was our B value. And the product of 8 and 3, the product of 3 and 8 is 24, which is A times C, AC. So that would have been the 6 times 4. The first and last. So same way here, notice 9 and negative 8, they add to plus 1, which is our middle term, our B value, and 9 and negative 8 have a product of negative 72, which is A times C, or 12 times negative 6, first times last. So how do we figure out the middle term? We want two numbers that multiply to first times last and add to the middle. That's complex factoring. Okay, so this method is called decomposition. So it's complex. These are complex trinomials. Just throw it in there, yeah. Complex trinomials. And so this is whenever our A value is not 1. And we're just reviewing the last couple days. All we're doing is reviewing our factoring, because we're going to need it when we look at our quadratic equations, and we're going to factor them. Right? Okay. to B. Plus 1. It's an arrow, sorry. B, A times C. Okay? Thank you. All right, so let's look at one example. Just to start. 2x squared plus 7x plus 6. So if we want to break this up into 4 terms, if it's 4 terms, we can use grouping. So what's the first thing you always ask yourself? G, C, F. Is there a G, C? Okay. Yes, I am recording this. Okay, GCF. Always check first. And you can sing if you want. My beautiful voice. Sarcastic. Okay, so 2, 7, and 6. Is there a number that we can divide in each one? No, there is no GCF. Okay, so now we can carry on. Is it a simple trinomial or complex? What's the difference? Well, look at your A value. Is it a 1? No, it's a 2. So because that's a 2, it's a complex, meaning it is so complex. We're going to have to use grouping. So we want 2 numbers that multiply to what? And if it, no.
7, 2.
12. Why 12? Where did 2 times 6? So multiply 6 and adds to 7, the middle term. Okay, 3 and 4.
These are complicated now.
It's called complex for a reason. Okay, 3 and 4. You should be proud of yourself, guys. No more Jesse. Okay, so 2x squared. So what are we going to do? Who are we going to replace? The 7x, we're going to replace it with 3 and 4. But what else do you have to include in that? 3x and a 4x. So it's the step before we collect like terms. We're reversing. It's anti-foiling. Okay. All right. So now, do you know how to handle something like that? You sure do. You should. Grouping, right? We group the first 2, group the second. So what's the greatest common factor out of the first 2? Just 1x. And remember, the first one, there'll always be a variable you can pull out as well. 4x and 6, what can we divide everybody by? 2. Okay, so where's that x going to go? In the front, put a bracket. So now we divide to figure out what's left over. 2x squared divided by x? 2x plus 3. Okay, plus 2, so you have to put the sign in front with it. Put our brackets, now figure out what's left over. 2x plus 3. Yeah. Okay, and last step. We can factor out 2x plus 3, and we're left with x plus 2. So treat this guy. This is one term, and this is one term. And they both have 2x plus 3 in common. So we're factoring it out, adding brackets, and what's left over, if we divide each by 2x plus 3, we're left with x plus 2. Yeah, exactly. We're dividing each by 2x plus 3. All right. Not so bad? One more? And then I'll let you start some homework. Okay, one more. So 2 numbers. Here, we want, first question we always ask ourselves. Is there a GCF? You get that in your head. Okay, no, 5, 7, 2, 5 is prime. Okay, so simple or complex here? Complex because of our 5. So because there's that 5, we want 2 numbers that multiply to 10 and adds to 7. What 2 numbers multiply to 10, add to 7? 5 and 2. It's like a game. It's kind of fun. 5 and 2? Well, because 10, a product, if you know your timetables really well, there's only 2 ways to multiply to 10. Now Jesse's being really nice. Okay. Okay, so 5x squared. So who are we replacing? replacing? Which term? The 7x we're going to replace with plus 5x plus 2x. And the 2, we leave there. So we're just replacing the middle term with those two numbers. Because now what do we have? Grouping. Okay, the first two. What can you factor out? 5x. And we're going to get to the point where you could just go like this. You don't have to write the division underneath it. But you can. There's nothing wrong. So we're going to divide each by 5x. So what's left over? 5x squared divided by 5x. Just x plus anything divided by itself? 1. And then here, what can we factor out? 2. Now in front, what are you going to write? Not just 2. Plus 2. We're left with x plus. Should these always be the same? Yep. If they're not, something went wrong. Okay, now we're going to factor out x plus 1. We're left with 5x plus 2. Let me show you one more thing to check in your calculator. The last part. So what we're doing here is there in each term, if this was treated as one term and this is treated as one term, they have x plus 1 in common. So we're going to factor x plus 1 out. So whenever we factor something out, we have to divide each term by it to figure out what's left over. The 5x plus 2. Okay? So that's what's happening there. All right, so on your calculator, if you grab your calculators for a second, I'm going to show you a really cool thing. I think I showed you this last year. But it was a while ago. So we can check these on our calculator. So all you have to do is store a number as x to start. So how do you store a number as a variable? Very easy. Pick a number. 1. Okay. 1. And then you push the store button. X. Enter. Store is STO right above on. Okay, so then let's use the new one we just did. Let's type in 5x squared plus 7x plus 2. And then you push enter. You're going to get a number. It doesn't matter what it is. You type in your answer. So bracket x plus 1 times bracket f5x plus 2. And it should be equal to that same number. And if so, bingo. I guess so, yeah. No, I could store it anytime. I could store it as a new number. Oh. Like when you go to graph, it'll just use x, a variable x. It won't store it as a number. Yeah. Yeah. Just in the calculator mode, will it actually come out as a number like that. Okay? And that's it for today. We're going to pick up the rest of this on Tuesday, and then you'll have more time for homework, but you can get started on some of the homework right now. So it's all of 1 to 10.